today's, I want us to digest IPv4. IPv4 stands for Internet Protocol version 4, uses a 32-bit addresses allowing over 4 billion IP addresses. So the concept of IPv4, I want you guys to know now in any network you're dealing with, IP address is a key, making sure that these devices communicate from the source to the destination. So now we need to know how these IP addresses operate and how to implement them within our network. So for now, I will start with the basics. So now when we say IPv4 address, the first thing you need to remember as a beginner, or as for every member, you need to know that IPv4 is a 4 numbers. IPv4 is 4 numbers. So when you are aware of this, that IPv4 is 4 numbers, now you now know that it's a 4-digit number. The next thing, these 4-digit numbers range from 0 to 255. It's a 4-digit number, and these numbers, each digit range from 0 to 255. Now these 4-digit numbers are being separated by a period. 4-digit number, each digit is being range from 0 to 255, and this 4 digits is being separated by a period. For an example, this 192.168.10.10 is an example of an IP address. As you can see, on 192, this 192 range from 0 to 255. 168 range from 0 to 255, 10 range from 0 to 255, and this other 10 range from 0 to 255. 4 digits, 1, 2, 3, 4. 4 digits separated by 3 periods. You can see this dot here, this dot, and this dot. It's been separated by 3 periods. But every digit you are seeing here, it's been ranged from 0 to 255. Now, this, you can see, the IP address, IPv4 address is being divided in 2 parts. It's been divided into 2 parts. We have the network and the host. We have the network part and the host part. Now, one thing you need to be aware of, now an IPv4 is 4 digits. These 4 digits, each digit range from 0 to 255. Now, this 4 digits is being separated by a period, and the IP address itself have 2 parts. The first part is the network, and the second part is the host. Now, the host, with the IP network or the IP address, this IP address will be divided. It have a dividing line to indicate the differences between the network part and the host part. The network part and the host part will be divided by what we call the max, the subnet max. 4 digits, each one range so 0 to 255, separated by 3 periods, which have 2 parts, the network and the host. The subnet max divide the 2 parts. It indicates, the subnet max indicates, tells you that this is the network side and this is the host part. Now, let's think of a scenario for you guys to grab this. Let's say, for an example now, you have an envelope. But this envelope, you want to send this envelope somewhere. Definitely, if you want to send this envelope, one thing, you need to indicate there an address. Let's say the envelope you are sending it to Second Stephen Street. For an example, when you are sending this envelope to Second Stephen Street, now Second Stephen Street is just like a network. It's like the network side of IP address. Now, when you put there, let's say 10 Second Stephen Street, that number 10 Second Stephen Street, the 10 there indicate what? The host. In the envelope, it said 10 Second Stephen Street. The Second Stephen Street itself is the network. Whilst if you say number 10, the number 10 there is the host. So just like that simple scenario for you guys to grab the simple scenarios when it comes to network. IPv4 address. IPv4 address, 1, it is 4 digits. This 4 digits, it is separated by 3 periods. Each digit, it range from 0 to 255. This 255 indicates what? The network and the host is being divided by a subnet max. To me, yes, it is an IP address, but I find it very, very difficult which type is this, because there is no indicator to indicate that, so to show us the network side and the host part. So for you to able to know that this is a real IP address, we need an indicator to show us that the network side of things and the host part. For you to know the differences, we need a subnet max, and this subnet max indicate divide this IP address. Let's say for an example now, the line was drawn between the 168 and the 10. If there's a line between the 168 and the 10, this indicates, tell us that the dividing line is between 168 and the 10. So if the dividing line is between the 168 and the 10, meaning the 192.168 is the network side of things, while the 10.24 is the host part. If the line move from 192.168 to 10, between the 10 and the 24, what will bear in mind? Now you now know that these three sides, the 192.168, 10 is now part of the network side, while the 24 is the host part, because we have learned that the subnet max divide these IP addresses. On this topology, with this slide, you can now see that we have two PC. We have mom's PC here and Aisha's PC here. You can see with this PC, we have 192.168.10.24, whilst this other PC here have 192.168.10.25. Now there is a switch. Within this switch, we have already connected what we call an Ethernet cable between the two switches. If you can see, if mom wants to communicate now to Aisha, this particular PC needs IP address. Now we have assigned the 192.168.2.24 to this particular PC, because PC can't just communicate within a network without IP address. Without this IP address, but the mom will not able to communicate to Aisha. So the IP address is very, very crucial. You need to know how to configure it, how to implement it. So now, we now know with this, you can see here, application, transport, network, data link, and physical. For example, we already know from our previous, when mom is within this application, is using like HTTP, within this transport, she's using what we call TCP, UDP. Now, in the network side now, here we work with IP address. Within this network layer, we are working with IP address. The source IP of this particular machine, mom's PC, and the destination IP address of Aisha's. Because if mom wants to communicate, one mom IP address, PC needs to have a source IP and the destination where the packet will be moving. We already know within this network layer now, IP address, we work with IP address through this particular layer. So now for an example now, we can see 192.168.10.24. This is also an example of an IP address. Now with this IP address, what will happen? We need to know, if you guys, you can see this line, this red line here. This red line indicates, it tells us that here, this 192.168.10 is the network side, while this other side, .24 here, is the host part. Because the line, this line, we call it the subnet mask, which divide between the host and the network, or within the network and the host part. Now, when under 192, the subnet mask here says 255. As long as the subnet mask here shows it 255, meaning this is a demarcation line, 255, 255. Straight away, this is a network, another network. Now the line is between the 10 and the 24. So here you can see a 0. So the subnet mask here is 255, 255, 255. What do these subnet masks mean? The subnet mask mean is I'm dividing, I'm showing you the network aspect and the host. And this part, 192.168.10 is the network side, because the subnet mask have already indicated below, which is the 255, 255, 255. This dot 0 indicate, you see, dot here is dot 0, not 255. This shows you, dot 0 shows you that this is a host part. So this address now indicates 24 bits. But when we reach to conversion, you will know more. Now, another example. You can see here 192.168.10.24. But the demarcation line now have moved from this 10 to 168. You can see now, if you check the subnet mask, the subnet mask now changed from 3 to 2, 255, 255. When this digit subnet mask is 255, it tells us that this is a network. When 168, the subnet mask says 255, it tells us that this is a network. Now you can see this last two digits is what? Is 0, 0. This tells us that you can see the demarcation line, the division line here. The division line shows that here is the host part. Now 192.168.10.24. The demarcation line now is between the 168 and 10. So you need to be aware when subnet mask changes. Now we can see the subnet masks have changed from here. So the demarcation line changed to between 10 and 24. Now when we move to the second example, the subnet address here, numbers change to 255, 255, just 2, not 3. Up is 3, down here is 2. This tells us that these 2 digits is the network side, is the street part. Example like Stephen Street is the street. While now this 2 part is the number, the house number. Let's say 1024. The house number is 1024. You understand? You need to know these differences. Now if we move to the third IP address, now you can see we have the 192.168.10.24. But the subnet mask changes. Under the 192, the mask says 255. As long as you see, when you assign this 255 to this particular number, this tells us that this 192 is only within the network. All these parts that don't have the 255, this part that don't have the 255, they are the host. The host identify the device. Example, from here, this 24, you guys can see this, .24. This .24 identify, this .24 is a unique IP address only assigned to this PC, which is mom PC. This .25 here is identify only this PC, which is Aisha's PC. 24 here identify mom's PC, while 25 here identify Aisha's PC. It's unique within a network. No other PC will have will have this IP address. Only it is if it is being released from the DHCP or assigned to another PC, but only this PC will have. It is unique within the network. So now we move. This 255 here indicate the 192 is within the network as side of things, while this 0 you are seeing 00 here indicate the host side. So if you can know these differences, that an IP address is a 4-digit, here you can see it's a 4-digit 192.168.10.24, then this 4-digit is being separated by what? By dot period, by this 3 period. Now this 3 period, every digit you are seeing here, this digit represent 255 here. It ranges from 0 to 255, 0 to 255, 0 to 255. But when you implement the subnet max, because now you want to know the network side of this particular IP address. If this subnet max you are seeing is not there, to me, it's just a normal IP. It's not, some people can even say it's not an IP address because there's no subnet max to indicate. So the subnet map is very, very essential because it is the dividing line. It divides the network. It tells you the network side and the host side. Now, you need to understand when we talk of an octet. In a normal form, example here, this 192.168.10.1 you are seeing, these numbers we call them octet. In a normal form, we don't just call them digits, but we call them octet. And every octet, this 192.168.10.1, every octet is being represented by 8 bits. Take note, octet. We call them now octet. This octet, every octet is now represented by 8 bits. If you can see this 8 bits, you can see 1, 2, 4, 8, 16, 32, 64, and 128. If you count them now, 1, 2, 3, 4, 5, 6, 7, 8, represented by 8 bits. You can see this 192. So this 168 is represented by 8 bits. This 10 is represented by 8 bits, and this 1 here is represented by 8 bits. We call these numbers octet. IP address, what? We call the numbers octet. Now, these numbers, you can see they are ranging from what? From 0 to 255. This one ranges from 0 to 255. How? Why it is ranging from 0 to 255? If you add 192, 192, 64, 32, 16, 8, 4, 2, 1. If you add all this, it will give you 255. That's why you need to be aware. This is an octet. This octet is being represented by 8 bits, and this octet range from 0 to 255. How? 192 plus 64. If you add it, it will arrive at 255. 192 plus 64 is 128 plus 64 is 192. 192 plus 32 is 224, 240, 248, 252, 254, and 255. If you add them all. So you see, now this is 168. This 168 range also from 0 to 255. This 10 range from 0 to 255 because why? A digit, an octet range from 0 to 255 because the octet is being represented by 8 bits. You can see here dot 1. Dot 1 is also an octet. This octet represents what? 8 bits, and this 8 bit is being ranged with what? From 0 to 255. So now, the subnet mask, this IP address, you can see, this IP address, let's say the subnet mask is 255. Now, if this subnet mask is 255, meaning this is a network. Now, 168, they say the subnet mask down here is 255. The 255 present, this is a network. This 128 is part of the network. Now, let's say this dot 10 also here we are seeing, down the subnet mask is 255. So if this 10 here is 255, meaning this 10 is part of the network. Now here we see dot 1 here. The subnet mask show here 255. If this is 255, meaning there is no host. All these are network. There is no host. But in a normal network, there should always be a host. So these numbers you are seeing are being represented by what we call binary, because computers don't understand decimals. Only we humans read decimals numbers. Computers don't read. Computers convert everything you are seeing within computers. It's zeros and ones. That's why we need to know how to convert, because computers convert these octet numbers to binaries. This 192 here, when computer convert it to binary, it will represent this way. You will now see it this form, in this way. So when it converts to 168, it will be, you can see it this way. When it converts, when the 10 is being converted, it will see it in this way, the 0, 0, 0, 1, 1, 0, 0, 1, and 0. When PC convert this 1 to binary, it will appear this way. Now, the binary numbers, we now need to learn how to convert these digits, this from decimal now to what? To binary numbers. So for an example now, how this conversion happen? Converting now from decimal to binary. How this happen? Now, one thing you need to be aware of, you need to know that what? We now have the IP address given here is 192.168.10.1. 192.168.10.1. This is the IP address assigned to this particular PC. So let's say we want to convert this IP address now to binary, because PC computers, when they are working logically, they operate in binaries. So we need to know, as engineers or tech or preparing, especially those preparing for certification, you really need to know how these conversions happen behind. So now, let's say octet. We have the first octet, the second octet, the third octet, and the fourth octet. Now we now know that these IPs, we can call them octet. The 192 is the first octet, 168 is the second octet, 10 is the third octet, and the 1 is the fourth octet. So don't be confused. You can now see them here: 192, 168, 10, and 1. So now we want to convert them to binary. What will happen? If this 192.168.10.1, we want to convert it from decimal to binary, what will happen? Now you need to, 192, you need to have this table. Example for those preparing for the examination. Take note. Don't even make like, even you understand subnetting in depth, please make sure that this bit table, you write it down. That's why even during the examination, you will have this laminated slip, you will have a marker, or in some centers they will provide an A4 paper with a pen to you. wherein make sure that you write this down. Don't just calculate it on that way. Make sure that you write this bit down before doing your conversions so that you won't miss, because missing 1, 2, 3 more questions, that will lead to another thing. So please, that those few questions, you don't need to miss them. Those conversions, have your bit, have your table set, do your conversion, take your time, do it. As for me, I do it that way. I write this down, take my time. When I see a question based on conversion, based on IP address, I make sure that I do my conversion before submitting the answer, because it is a one-way flow. When you submit, there's no way that question gone. Next question, but it's a one-way flow. After submitting, no way that I forgot, I need to check that, to change that IP. No, it's a one-way flow. So please take note of that. So now, we now say the first octet is the 192, which is the first octet. The second octet here is the 168. The third octet here is the 10, and the fourth is the 1. So now let's convert this. If you want to convert this, conversion starts from the right here. You move, you start it. I don't know, because when I'm communicating with you, you see, you always start it from 128. You move to 64, 32, 16, 8, 4, 2, 1. When you are aligning, you always start, because now you are converting what? From decimal to binary. You start from the 128 to 1. Now let's say this is 192. I want to convert this 192 here to a binary. How will you do it? We have what we call ones and zeros. Ones and zero. If the bit is on, we call it 1. If the bit is off, we call it 0. So just be aware of that. When the bit is on, we call it 1. When the bit is off, we call it 0. So now, you can see this is 192. So this 192, what? 128 and 192. Which number is more bigger? We can see the 192 is bigger. So meaning this 128 can go into this 192. So meaning the bit is on. This 128 can go into what? Can go into 192. So the bit is on. If you see the binary bit here is on, it's 1. You see, we have put it here, it's 1. It's 1. Let's just indicate it down here. So you can see, because this 192 here, the bit is bigger than this, meaning 128 can go into 192. So the bit is on. So what next? So now we need to add numbers that can give us 192. Two things. 192, I need to add bits within these tables that can give me 192. So now we already have 128 here. So if you can see, 128 is here. You see? We already have 128. So but if we add one, we need another digit, which is for me to get the 192. If you add 64, 128 plus 64 is 192. If you add 128 plus this 64, what will happen? It will give you 192. Let's just use our calculation for you guys to see. Fine. So now let's take an example. We can see, let's add 128 plus 64. You see? Because these two bits, if we add these two bits here right now, these two bits can give us 192. So meaning this bit also supposed to be on. Now you can see 192, if we add these two, 128 plus 64, it gives us 192. So Just forget, yours need to add now 0, 0, 0 because we have already get the 192. So the rest could be 0, 0, 0, 0, 0, 0, 0, 6 zeros. You understand? So now, from the first octet, what happened? This 192, which is decimal, now the bit side, when we add 128 from the bits table here, plus 64, it gives us 192. In binary now, we see it, computer see it as 1100000. This is how computers see it in binary now. So now the second side, this second is 168. 168. Now we want to convert this 168 to binary. What you need to do, you consult your bit table, because what they say, this octet, this is an octet. This octet represents what? 8 bits. Where are the 8 bits? These are the 8 bits. You always align the 8 bits in power of 2. These are the 8 bits. So now, if we are looking for, if we want to convert now this 168 to binary, what happened? Now we go 128. You can see 128 is smaller than 168. So meaning this bit is on. Meaning this bit supposed to be on. 128. 128 is smaller. 168 is bigger. This 128 here, guys, please. This 128 here is bigger than this 128. This 168 is bigger than 128. So meaning the bit is on. You turn the bit on. So now you can see it down here. 128, you bring it down. The bit is on. So but if we add now 128 plus 64, what will happen? It will arrive at 192, meaning 64 is too bigger. We need to add numbers that will not exceed this 128. If you add 64 to this, take note, it will give us what? 192. It will give us 192. So we don't need this 64. We look for another number. So if this 64 is bigger, what will happen? The bit is off. You see? 128 here, the bit is on. Because what? 128, this 168 is bigger. So now this bit is off. If we add these two, it will give us 192. The bit is off. So if we try now to add 32 to 128, what will happen? Let's punch. Let's say 128 plus 32. It will give us 168. So meaning the bit is not, it's not more than this 168. So meaning this 32 is good. We can use 32 because if we add 32 to 128, it will only give us 168. So we say the bit is on. 64 is over. So the bit is off. 32 is on. The bit is on. So but when we punch, it tells us it is what? 160. We still need a bit to round this up to 168. So now we check our table. If we add 16 to 32, definitely it will be over. It will be over what? It will be over 168 because we already have what? We already have 160. So but if we use this 8 bits here, it will round up to what? Look at the calculator. If we say plus 8 now, it will give us 168. So meaning this 16 here, 16 is over 160. It will give us 176. It's over. So now we say the bit is off here. But if we use 8 here, the bit is on because 8 now plus 8 will give us 168. We arrive at this number, which is 168. So now what will happen? The rest, this other 4 bits will turn then off. So now can I say off, 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 because the what? The 168 will arrive at the 168. So now the binary noun for this 168, the binary noun for 168 is 10101000. As you can see here, this is the second octet, 168. Now you need to add noun. If you add noun 168, 32, 8 can give you 168, which is, we have used this 168 here, we have used this 32 here, we have used this 8 bit here, but all these others are off. You can see the 128 here, we use it. The 64 is 0. The 64 is off, because if we add the 64, it's more than. We write this 32 here, because the 32, if we add it to the 128, 128 is give us 160. It's good. So when we move to the 16, if we add the 16 is more than this 168. So we turn the bit off. But when we reach to this second, the 8 bit, what happened? We add the 8 bit to the 168, which is 128 plus 32, 168, plus this 8, it gives us what? 168. So the bit, the decimal now here is 168, but the binomial now, after converting this 168, it now gives us 10101000. Guys, please take note of this conversion. Now we move to the third octet. The third octet here is 10. Look at it here. You can see this is the first, which is the 192. This is the second, which is the 168. This is the third octet, which is the 10. So this 10, we need to convert this 10 to binary. PCs, computers communicate with this decimal as binary. They don't communicate as decimal, they communicate as binary. So now let's convert this 10. This is the 10, the third bit. So now you need to consult. We consult our what? The bit table. Why? Because this 10 here is a octet. Take note. This 10 here now is a octet. This octet you are now seeing represent what? 8 bits. This table, don't be confused. This table is the 8-bit table. So with this table now, if we now want to convert this 10 to a binary, what will happen? We said we start it from where? From this 128, 64, 32, 16, 8, 4, 2, 1. So now let's say 10. You can see 128 is it's very, very higher than 10. So straight away what happened? We say the bit is what? The bit is off, because this 128 here you are seeing here is too higher. It's too big. It's bigger than 10. So the bit is off. Now we move to this 64. You can see when we tally 10 here, this is the 10 bit. This is the 10, this is the octet here. So 64 is bigger than 10. So if 64 is bigger than 10, who can tell me what will be the will the bit be on or off? Guys.
It will be off.
The bit will be off, because you can see that this 64 here is bigger than 10. So we say the bit is off. So now we move to 32. So 32 here now, you can see the octet here is 10. And we want a binary for this 10. But if you check now the bit table, this is 10, 32 is bigger than 10. So if 32 is bigger than 10, the bit is on or off?
It should also be off.
Off. So you see, so now we move now to the 8. Now you can see here now, this is 10. Our octet here is 10. But on the bit table, we can see 8. So now, if the octet is 10 and the bit is 8, will the bit now be on or off?
It should be on.
On. Now the bit is on because this 8 can go into 10. So you see, now this 8 now can go into 10. So now the bit is on. So now we move here. When we come to this 8, but we are yearning for what? 10.
10.
We need to round this 8 to 10 because the octet here shows it is a 10. So if the octet shows it's 10 here, now 4 is here. If we add 4 to 8, it will give us 12. So meaning it is over 10. So will the bit be on or off?
Off. It will be off.
It will be off. The bit will be off because you see this is 10 here. Please don't be confused. This is the 10. This 10 is the octet. This octet represents, this 8-bit represents this one octet. But now 8 here is can go into 10. Great. So now what do you have? 8 bits. What do you have? 8. So if we add 4 now to 8, it will give us 12. So meaning it is over 10. So we don't need to use this 4. We say the bit is off. We are looking for a bit here that will add to this 8 to give us this 10. So now if we move now to number 2 here in the table, if we take 2, we add it to 8, it will give us 10. So
10.
on the 2 now, will the bit be on or off?
It should be on.
The bit now will be on because if you add 2 to 8, what will happen? It will give you 10. So now the last bit now will be totally off because we already have our 10 bits we are looking for to give us this particular 10. So you see, so now the binomial for 10. The binomial now for 10 is 0, 0, 0, 1, 0, 1, 0. If you take these zeros, you align them under this bit now, you see, this 0 now will be under this 128, this other 0 under this under this 64, this other 0 under the 32, this other 0. I think we need to have one more zeros here. This other 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. This other 0, which is under the 16 is 0. Now, under the 8 now, we have 1, which is the 8. The 4 is off. Under the 2 is 1. And this one is 0. So you can now see binomial. Now, in binomial action now, our binomial now is 0, 0, 0, 0, 1, 0, 1, 0. Now we move to the 4th octet. The 4th octet now is this. Dot 1, this last one here. Dot 1 is our 4th octet. You can see for this 3rd octet here, you can see this same 0 we add here. You can see this now 0, 0, 0, 0, 8, 2, 0, 0 plus 0. You see, it is equal to now to 10. If you add this 8 plus this 2, it gives us 10, which is meaning this binomial here is correct. So now our 4th octet now, which is 1, what happened? We check the octet. This is 1. Take note, though this is 1, but this one still represents what? 8 bits. Because this one is a octet. This octet what? Represents this 8 bits from here to here. What now happens? If we want to convert this one now to a binomial, we say 128. 128 is what? Is over 1. So the bit now is, guys, now 128 is more than 1. So the bit is on or off?
Off.
The bit is
Off.
off. The bit is off. So now, why the bit is off? Because this 128 is bigger than this one. I think in simple terms, this 128 you are seeing is bigger than this one, and this one represents 8 bits here. So now let's say we move to the 64. 64 is bigger than what? 64 is bigger than 1. So
1.
the bit is
Off.
So you see 32, same thing. 32 is bigger than 1. So the bit is what? Open your mic.
Off.
Bit is what?
Off.
The bit is off. So 8 is bigger than 1. So the bit is what? On or off?
Off.
Off. Now the bit 4 is bigger than 1. So the bit is on or off?
Off.
Off. So 2 is bigger than 1 and the bit is
Off.
So when we reach to 1, now we can now see 1, 1. 1 and 1 is equal. So now the bit will be what? On or off?
On.
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 Now the bit is now on. So you can see that now this fourth octet, we have convert dot 1 here. The dot 1 now to binary. So now the binary now for 192.168.10.1 is this you are seeing below. Tells us how to convert now from binary to decimal. You need to understand this. How to convert now from binary to decimal. We are still using these 8 bits. Now let's have an example. See, now you have been given this 11 0 0 0 0 1 0 1 0 1 0 0 0 0 0 0 10. This with this binaries now, you need to convert. You need to convert this binary to decimal. We need to follow the reverse. Now we can implement now the reverse order of this. With this reverse order now, what you need to be aware of, you already always, as I advised earlier, write down this 8 bits from 128 to 1 or from 1 to 128. Now with this binary, you take these binary numbers, make sure that you indicate it under this bit. This one you put it under the 128, this other one you put it under the 64, and the zeros go because these are 8 bits also representing this 8 bits on the table. So now here on the decimal aspect, this one represents what? This one represents the 128. You can see it here in decimal form here, 128. And this other one here, you place it under the 64. You see it, this is 64. If all these other zeros now, you place it under this degree. You can see it. When we add them, it will give us now what? 192. Now we have placed this 1 1 under this. Now after adding them, it arrives at what we call 192. If you add 128 plus 64, it will give you 192, which is these two 1 1s. So now we move to the second binary octet. With this second binary, the same thing, you need to implement the same method. You write down this bit. Now you take these bits, you put them under this bit. You can see you start from, always I advise you guys, please, you start it from 128 to 1. So when placing it, don't start placing it from here to this. You place it from here to 1. So now if we take this one, you place it under the 1, 0 under this 64, 1 under this 32, this 0 under 16, 1 under 8, and this 0 0 under here. So now the second, which is the second octet, what we will see now, see that 128 plus 0 plus 32 plus 0 plus 8 plus 0 plus 0 0 0 which arrive. Now this binomial here, after converting it, it will give us 128. After converting this binomial, you will arrive at 128. How? If you use this 128 plus 32 plus 8. Now let's just use our punch. Here, let's say, which is 128 plus what? Plus this 32 here. Plus 32 plus what? Plus 8. You see, we arrive at 168, which is correct. So now you now know that the first decimal, after converting this first one, it arrives at 192. The second is 168. Now the third octet, this third octet. Now you take this same octet. That's why you have your paper, you write down this, you draw your lines. You know, I'm using a mouse. I'm not using a pen, but I'm working on that to have a pen that we can able to write on the screen. You guys can see it. So now you can see this 0, 0, 0, 0. You place these zeros under this digits. Same method. Same method. You select 0, 0, 0, place them under this. Now you can see the 1, 0, 1, 0, 1 under the 8, 0, 1, 0. If you add this digits, it will arrive at 10. 8 plus 2 is 10. So now we move to the fourth octet. The fourth octet is what? Is the binary here is 0, 0, 0, 0, and 1. So we need to convert this binary now to decimal. To convert it, pretty easy. Converting to binary is pretty easy. You only need to have this your bit table. Take this, put them under, and convert it. So it will arrive at now the IP address. The hidden IP address here is what? 192.168.10.1.